Right. Well, that's me. You've all seen me today. This is a talk about what ships do to the environment, but it doesn't include port. That would be another book if somebody would like to put it together for IMarEST. I think it would be an excellent topic. Or alternatively, we could get it published at Cambridge University Press, with whom I have close association, which is why I always have to comment about conflict of interest when we talk about publications. Right, so I want to talk about a few things today. Firstly, the importance of shipping. Silly for this audience, you guys absolutely know everything about it. I'm going to talk about emissions from ships, and there's different kinds, so we'll see on that. We'll look at the impact of some operational activities. And again, there's some people here that know far more than me, so I will only take questions and comments at the very end. And please be nice. And then there's just a quick rundown on sort of legal and industrial considerations, because we've got the IMO on our doorstep here, and the IMO has been fantastic in terms of maybe slow at times, but in terms of bringing in environmental protection. So we have this wonderful thing where engineers and scientists invent technologies and compounds. They go out into the environment and oops, that wasn't a good idea. And really realize all the reasons why we shouldn't use that. Go to IMO, and eventually IMO says, oh, no, you're right, shouldn't use that. So they stop doing it. And so, of course, there's all kinds of conventions and things that have come out of IMO based through that, let's call it a trial and error process. So the other considerations then, which we don't have time for today, some of which would be really fun to talk about, shipwrecks, cargo losses, nuclear powered vessels, and shipbreaking. And okay, the importance, this is an older guy. His replacement is going to be at our dinner tomorrow night, right? Sitting up beside me at my table. So basically, though, we can see that shipping is essential. It's absolutely of global importance, as it was then, it is now. Shipping facts, 80% of world trade is by sea, billions of tons of cargo. Most environmentally efficient way of moving the amount of material from one place to another. We'll see that later on. 80,000 ships owned by 10,000 companies, and employs a lot of people, both at sea, but not forgetting also on shore. I love this. This is what shipping lanes used to look like a long, long time ago. And you can see the Atlantic was pretty important. I love that North Atlantic crossing, and it's going into Hudson's Bay. And I'll bet not many of you knew that the first British colony in Canada, or probably North America, was actually at the southern end of Hudson's Bay. And it's still a tiny little town today. That's really important now for tourism. In the old days, of course, it was part of Hudson's Bay Company and was important for sending furs home. So that was it. You can see the Pacific is pretty quiet. How things have changed. So today, shipping routes, again, across the Atlantic, but you can see the importance of Asia within the global trade. So, shipping is important. There's a lot of information here, but the first time I had lunch with the chief executive or the director, whatever he's called, for the International Chamber of Shipping, took me to a lovely place in Westminster, and he said, why should we be worried about invasive species? Because, we've been transporting ships around the world for centuries and using ballast. And I said, well, that's so well and good, but the world of today is not the same as the world of yesterday. And the changing biomes are really important. And so here we have, and it's a little bit hard to decipher here, but you can see that the colored patterns are in different places. So let's look at one in a little bit more detail. So this is warm temperate species distribution around the Osbar region, really. And so this is the 1958 to 81. There it is in 82 to 99. And there you can see, so in all of this, there's a northward progression of the species, these warm temperate species. So their habitat, their biome has changed over time. What does that mean? Well, it means if you fill up a ship with ballast water in Pakistan, where cholera exists in the water, and you empty your ballast waters in the waters around the UK, at once upon a time, that wouldn't have mattered, but actually, the waters now, the cholera would actually be viable. And so it changes the public health threat. And that's just cholera. So there's all kinds of other things that we need to worry about in terms of invasive species. And I'll get to that. Emissions from ships. Lots of things go out, lots of things come out. I don't have time to talk about all of them, but I will talk about air pollution, oily waters, and ballast waters. And of course, you'll recognize the ballast waters. We have a scientific essay. We're looking at that. So if we go into detail then with some of these, contaminants in the sea, lots and lots of things that we consider contaminants have actually been airborne. So atmospheric input, and you can pick that up in shipping lanes and the like. Impacts on the surface ocean. There's a whole series of iron fertilization experiments were done. And it turns out that in many oceanic waters, iron is the limiting nutrient. So often people think about phosphorus being the limiting nutrient, but in fact, in marine environment, usually it's iron. And so you can see put an input of iron into these things. What are ships made of? Yes, there's lots of it can come from that. So on the positive side, then, iron is an important nutrient. And if it stimulates algal growth, then that leads to CO2 removed from the atmosphere. So, hey, that sounds like a good idea. Let's do it. Of course, there are other things as well. And we talked about, already showed you contaminants that are airborne, so derived from atmospheric aerosols and their effect on marine phytoplankton. So the negative side then, other metals, again, copper is actually a micronutrient as well, but in the kind of concentrations that we put in, it's pretty toxic. Oil pollution, well, there's spectacular events all the time, isn't there? Something happened recently in the North Sea. I went on holiday to Tobago in February last year, and just before I arrived, there was a tanker incident on the East Coast, and luckily I was staying on the West Coast, so the beaches weren't affected. Although just after I was there were shark attacks, and so they closed all the West beaches as well. But anyways, oil pollution from ships. And again, this is a role that IMO and MARPOL and stuff has had a huge impact on in terms of limiting the pollution that comes from ships. There's operational sources which have to be minimized. So ballasting, cargo tank washing, bilge water lubrication, and sort of lightening loads. But MARPOL has been wonderful. There's all kinds of other things as well in terms of restrictions that may be put regionally. So for instance, in the Baltic Sea, they require bilge water to be emptied into specific receptacles. And again, this is the interaction between ships and port activities is kind of interesting because there's lots of things that ships and ship owners would like to do at ports that ports don't have the facilities for them to do. You read that, didn't you? So were you a good guy or a bad guy?
Very good.
Silly question. Okay, despite the couple that I just mentioned, there's some few fairly significant. And usually when you start talking about oil pollution, people recognize names. I guess Torrey Canyon sort of is one that, or you, some of you, most of you probably weren't old enough to remember the raft trying to bomb the thing. Yeah.
I was.
Yeah, I was old enough too. We just.
My parents told me about it.
Yeah. You know, I remember lecturing in Auckland at this class, and I started talking about the war in Vietnam, and they all just looked at me. And I said, "Oh, you weren't born then, were you?" I said, "You don't even know the Beatles," which of course they do. So reduction in major oil spills, we can see, you know, this is going through from the 70s until the 2000 teens. So massive effort. But as we saw last week, whenever there is an incident, then it still brings incredible attention, spotlight to bear. And I dare say sometimes some ridiculous cleanup costs. The Exxon Valdez incident, you know, it was causing $30,000 to $50,000 to clean one seal. You have to ask yourself in a country that there's no free health care, whether they're better off than some of the poor Alaskans that live nearby. Anyways, let's not be too political. Atmospheric emissions of SO2. All relates to the, I'm gonna have some water, the quality of the fuel. And there's been big pressures on reducing the sulfur content in the fuels that people burn. And clever atmospheric scientists can measure all of this. And so you can get, as you see here, basically the cruise tracks. And then the English Channel, North Sea, and the Baltic, they declared, for lack of a better word, sort of a clean zone where reduced sulfur content fuels had to be used. So the real question about all of this, and indeed about a lot of IMO conventions, is enforcing or monitoring the compliance. And when I was at PML, a couple of clever young lads set up an atmospheric chemistry monitoring center at Penley Point. So this was trying to get a place in the south of England where you might get reasonably clean air. But of course, it is on the English Channel. And so there are a lot of ships go by. But, you know, they could measure interesting things and you could see ship plumes. But the bottom graph is the one I want to concentrate on. And what they were finding was that once the regulations for low sulfur fuel came into effect, they could actually measure that was having an impact, a beneficial impact in this case, an influence on the atmospheric quality. Why do we care about SO2? Well, it does all kinds of nasty things, right? In terms of corrosion and production of ammonium sulfates and the like. So there you go, 95% compliance with respect to local traffic in the English Channel, basically instantly. So people actually were pretty conscientious about switching to the lower sulfur fuels once they hit them. I think it's Falmouth, I think is where it starts. Ballast water. Right, so my colleague at International Chamber of Shipper, why do we need to worry? Well, ballast water is a great way of moving organisms around the ocean. And generally, when you introduce new things into a habitat where they hadn't existed previously, they're going to cause havoc. And that certainly was the case with cane toads in Australia, with Europeans in North America as well, might add. They pretty well created havoc. They killed more people with smallpox than they managed to kill other means. So basically, things can go very wrong. And you know, there's a long history of understanding this. And certainly the early biofouling, they put copper plates on the bottoms of ships because they knew that copper was toxic and it prevented some of the fouling. So, these observations go back to the 17th century. Darwin, clever bugger, he recognized that barnacles were being transported around. Algae blooms in the North Sea had come from Asia. And then in 1970, again, clever scientists telling IMO, hey, we've got a problem here, we need to do something. It took a long time to get things under control, partly because the recognition of problem came a long time before the recognition of a solution. Okay, so I think people may be aware that it actually took decades to develop and get in place appropriate ballast water treatment systems on ships. And retrofitting them was costly. And anyways, I talked earlier about cholera. And in fact, there was actually a case in 91 where ports in Peru were affected by cholera that had probably come from Pakistan. The real famous one is Miniopsis. This is a North American comb jelly. Anybody here heard of it? Do you know what we're talking about? So this is basically a little jellyfish, and it invaded firstly into the Black Sea, and then it eventually got into the Caspian Sea because there's direct contact connection between the Black Sea and Caspian Sea for shipping. And ships didn't deballast in the freshwater environment en route, and so they emptied ballast in the Caspian Sea. But basically what happened was it collapsed the fisheries, sturgeon in particular. We had a 90% reduction of sturgeon levels in the Caspian Sea. It also affected kilka, which was like I don't know if it's a sprat or something, I can't quite remember, but it was an important fish for artisanal fisheries and for the local population. So it was the food source for them, as well as the sturgeon. So massive social and economic impact. So Tim, this may be a little hard to see, so I apologize for that, but it's a really great sort of overview of sort of 10 most unwanted. And cholera is there. There's various crabs. Some of them are European crabs, so not everything nasty has come to Europe. We've contributed our share of chaos elsewhere. The zebra mussel, I think, pretty sure people have heard of that, was a big problem in Ireland, I know. It was also a big problem in the Great Lakes in North America. So, there's lots of organisms, and you'll see on this, some of these obviously are not from ballast water, because the crabs actually, badly biofouled ships can have quite exotic ecosystems on them, which includes crabs living there quite happily, moving around the world, and every now and again dropping off and starting new families elsewhere. So the other thing I want to look at is sort of the impact of operational activities. So this is sort of physical effects, noise, biofouling, and wildlife collisions. So ship wake and disturbance can cause a lot of problems, and as does the aeration of propellers, propeller wash. Grounding can be even worse, and then there's anchor damage. So these lead to the resuspension of sediments, which in turn can lead to coastal erosion, disturbance of wildlife in and out of the water, disturbances inside ports and marinas, and you've all seen when propellers are going inside sort of shallow waters, the water becomes terribly turbid. And when people are ballasting that water, then they wind up with huge sediment loads going into their ballast water systems. And there was, I guess I heard talk recently about how easy it was to clog up the ballast water treatment systems. If you're ballasting during a time of these high sort of sediment loadings, so which is not recommended.
Yeah, can you move the microphone?
Oh, sorry. Okay, I can do that. Why didn't you speak up earlier?
Yeah, because you were stood over there earlier.
No, I've been here a long time. I'm having a look. So you get damage to moored structures and like as well. Propeller wash, ships can have all kinds of propellers now. I love a story in the early days, a research ship from Scripps. It came to park in a heavy duty port. It pulled up besides where it was going to berth, turned on its thrusters, and it just went sideways into the hole. Now that's sort of common, I guess now, but it was first done. People were just stood around, dropped their jaws watching all of this. So again, propeller wash, same kind of things, sort of resuspension, killing off organisms, physical damage, scour, not to mention the scour on the backs of things like manatees and who knows what else that gets in the way. Anchor damage. I can imagine you throw this very heavy piece of metal down into the sea, and it can have all kinds of issues. And in particular, cruise ships in coral reef environments have been known to cause a lot of trouble in terms of dislodging the coral that's there, breaking up bits, and basically killing off coral. So you wind up with white patches. And the same thing can happen with the bigger ships in deeper waters, seabeds, when they're anchoring offshore. And noise. This is an area that's, I guess, is coming vogue in the last 10, maybe 20 years. We never really thought about what we were doing, but the frequency effects of sea noise, predominantly from propeller rotation, but from other things. The cavitating noises, for instance, has quite a disturbing effect on several organisms in the marine environment. And other shipboard noises, particularly from carriers, cargo ships, tankers, and bulk carriers. So this is just all the other bits and pieces that are going on board. And I'm sure all of us who've ever been to sea in a ship, except maybe cruise ships, will know how noisy they are. Particularly as I had one day, was an internal noise. We were going into ice fields in the Arctic, and my cabin just had to be in the curvature of the bow. And about 3 o'clock in the morning, when we hit the first ice floe, that was an interesting moment, let's just say. So ship noise, what does it do? Well, it's got effect on marine life. So in particular, things like the acoustic masking can have an influence on behavior. And so you wind up with avoidance behavior, for instance, but just a lot of changes in the way predator-prey interactions may be and the like. So changes to behavior, to migration patterns, perhaps, and physiological effects. And so it can affect, I mean, we're quite used to thinking, we're quite used to thinking about the impact on whales, but also at the fish and invertebrate level. So stress induced, so inhibition of the immune systems, stress hormones, think the same thing happens for us. I have to say, last night in London was considerably noisier than back home in Plymouth. So yes, if I seem stressed today, it's London traffic must have done it. Oop. Oh, that's new. So you wind up with displacement activities, avoidance behaviors, changes in surfacing and diving behaviors, and changing in acoustic behavior. So basically, they can't live their normal life because the sounds that they're here interfere with either the sounds they make or the sounds they're listening out for. I guess there's submariners here who probably have got their own tales to tell. So biofouling, what is it? Well, it's the growth on the outside of ships. Anybody that has a yacht or a fishing boat or whatever certainly knows what we're talking about. It can be microfouling, so this is like a biofilm, and there's a lot of studies been shown about what attracts sort of the first microorganisms to inhabit the surface of the sea, but it gets into macrofouling as well. So hard barnacles, worms, mussels, soft ones could be the sponges and the like. And as I've already said, once you have quite an ecosystem form, then you get organisms as large as crabs living there. And the biofouling is quite variable depending on region and season. A group at Female Application were running a project up in the Orkney Shetlands. And it was basically doing some biofouling studies for a client. And they'd go up there and pull these plates out of the water and examine them. And they were working with a bunch of guys who were also doing tidal power generation. So these things, you know, once limpets and stuff get onto stainless steel, they can basically dissolve several millimeters of the steel. So these guys, these workers were laughing at, oh, look at that, you know, you've got all of this biofouling on there, and look at all the damage. And they pointed out that on their blades were these little dots. And they said, those are these, and that's what's going to happen to you. So it's a real issue. So not only in terms of sort of power generation and stuff, but in particular in terms of vessel performance degradation and biofouling. So basically, the more stuff you've got on there, it affects speed and performance, and particularly increased fuel usage quite considerably. So I don't want to go into details, but basically, the more fouling you've got and the longer you leave it on, the less efficient your vehicle becomes over time. And of course, all good ship owners want their vessels to be as efficient as possible because time and fuel is money. So there was a lot of work that gone into different formulations. And I guess I already talked about the very earliest days with copper plates. That soon got transitioned to copper containing paints. And then there was a wonderful invention called tributyl tin that was put into paints, and in particular, yacht owners loved it because it wasn't grungy blue or red, muddy red. You could have any color you want. So all of a sudden, you start seeing white and yellow yachts appear. And then a very clever Frenchman friend of mine made the link between tributyl tin and the chambering of oysters in Arcachon Bay in the south of France. If it had happened in any other country, maybe it would have taken longer for a reaction. But he made the link. British scientists said, oh, no, you don't have enough data. The French basically banned the use of it in small vessels in ports like Arcachon Bay. And of course, Claude Delzio was right. It was the root cause, the problem that they were seeing. So basically, oysters were developing lots and lots of shells inside and no meat. And of course, the French, among others, like oysters. And so they reacted. In the South Coast, and particularly in Plymouth, it was sort of the seat of major research looking at IMPOSEX. So this is where gastropods, so marine snails, actually females grow penis and become non-functional females. So you can see pretty detrimental to the local populations of gastropods, not only in Plymouth, but Plymouth was, there's a lot of research was done at Plymouth Marine Lab and the Marine Biological Association. So little things about, just to show you then, how the non-native species in 3 of our European waters has changed over time, and in particular in the Mediterranean Sea. So you can see the impact of bioinvasion there. Okay, so legal considerations. So this I showed you before, and the blue boxes down the bottom show, and this may not be right up to date, but basically shows the kind of work that IMO has been doing in terms of targeting these different types of pollutions or emissions that are coming from ships. So a lot of good work being done. As I say, sometimes it's a little bit slow, and coming into force does require, unlike other UN organizations, requires a certain percentage of global ship tonnage to come into the fold. So, you really need some of the big 4 shipping countries, Panama, Bahamas, Liberia, and the like, to come on board with new conventions. Otherwise, it can be blocked. So, the objectives are primarily technical, but also can be economic when you're looking at IMO, and particularly MEPC, is concerned with protection of the marine environment. So that's really looking at prevention of pollution, eventually mitigation of pollution, but also maritime safety. So there's 50 conventions, so obviously not time to go through them all, 100 resolutions and recommendations. MARPOL and the London Prevention are the real important ones. Then of late, the Ballast Water Convention is really important. The International Chamber of Shipping has got a role. Sometimes as an advocate, and sometimes I think as a break. But they at least claim that they fully respect the role of IMO as its global regulator. They do participate in the development of new and revised regulations. Yeah, I can see various doubts in the audience here. I think sometimes they help and sometimes they hinder. It really depends on the particular task at hand. But I think what is fair to say is that they want a level playing field. So when regulations come into effect, they do want to make sure that it's for everybody to abide by, and nobody will get particular economic advantage by regulations coming into play. So there is their sense of fair play comes from economic considerations as much as anything. I talked already about the IMO global sulfur cap in fuel. So, 2005, 4.5%, and it's gone down more recent times to 0.5%. So that's got a specific effect on sulfur dioxide emissions from vessels. And CO2, as much as they try to get away from it, the shipping industry is actually responsible for large amounts of CO2. So over 2% of the global emissions come from shipping. So right now, and I saw when people talked about your membership survey, is Jody still here? No, very smart, gone home. Basically, the whole concept of zero emissions and new fuels is something that's really is high impact right now. So basically, how can we reduce the CO2 emissions So there's various things. I mean, solar batteries isn't going to work on oil tankers. I think people have been trying with large wind sails, and that's very noble. But again, probably not the right way to go about it. It's going to be interesting to see what they do about hydrogen generation. But basically, for a long time, with sort of IPCC, well, sorry, with the COP meetings, the shipping industry sort of got away with things for a long time because of the recognition it's 90% of the world trade. But I think that as time goes on, more and more they will have to do in terms of reducing shipping emissions. But here's just to show you that, in fact, it is a good way to move goods around. On a scale here of 3 compared to 435 for an airplane. So I think this graph does make me feel guilty that I'm flying away next month. I have a holiday, but it will be on the ship. So that part of me feels good. So the take-home messages I have here. Shipping is vital. Okay, we absolutely need it. But they're an important source of air pollution and of water pollution. And again, global initiatives are trying to mitigate and prevent as much as possible. They're an important vector for invasive species, and particularly from biofouling and ballast water. The operational activities can affect the marine environment. And you'll note I didn't talk about shipwrecks in this. So, that's another way that things happen. There are longstanding international efforts for effective pollution control, and hats off to IMO for doing that. IMO is keen, and to a certain extent, they're supported by ICS. But there's still lots of things that are going on. And in particular, we know that IMarEST has got various special interest groups working. Nero would be quite annoyed with me if I didn't mention the whales SIG that we have, and he's doing a lot of work in terms of whale collisions and that kind of thing. And we have plastics group who've been a little bit quiet of late, I think. We've got ballast water group, as does IMO. So we dovetail very nicely into the IMO ballast water group. And out of the blue, I got an email message a couple of weeks ago from my very good friend, Wendy Watson-Wright, who said, "Oh, you're giving a ship's pollution talk. Will it be aired? Will it be streamed?" Now, Wendy is past, I mentioned this earlier today, she is the past executive director of IOC in Paris. She's had all kinds of influential positions, ocean elder and the like. And she wanted to make sure that I did mention GIZAM. And so, Wendy, if you ever get to watch this, either live or in the future, I'm mentioning GIZAM and the excellent work that they do. Which includes some IMarEST members, and certainly I know that Chris Vivian chairs one of the working groups. But they have they've got, and at four they're extremely active right now. But over its history, they've involved all kinds of different things. And the acronym Group of Experts on the Scientific Aspects of Marine Environmental Protection, which is why we only call it GIZAM. So on that note, I thank you for your time. I will take questions, but I don't promise to be able to give answers. And I know that there's some people here who know more than me about some of these topics. Patty, you got a question?
Yeah, thanks. That's a really fantastic presentation, and I'm looking to your year in charge. I'm sold on zero carbon nuclear propulsion, so thank you. So where do you think this sits with regards to commercial shipping, and where do you really think what do you think the point is in terms of size? my personal opinion is you're gonna go massive to make this work.
Yeah, I think if it does come about, I mean, it has happened before, right? The Savannah was a nuclear powered ship. If you buy my book, there's a whole chapter in it on nuclear powered.
I'll buy your book if you buy mine. Don't do it.
I hope yours is a lot cheaper than mine, because mine is exceedingly expensive.
Could be worse, okay?
Yeah, it's pricey. No, in terms of the future, I mean, let's face it, you had oil tankers crash. The idea of having a nuclear powered vessel crash, I think, is just unacceptable to any country outside of Russia, probably. They have a role to play, and obviously, you know, aircraft carriers, which are very big. They've also been used really well in terms of ice breaking. There's a lovely film. It's quite funny because it was some of my colleagues from Rimouski were on board a Canadian ship, and it was huge, big PR because they were going up into the Arctic and they were going to make oceanographic measurements at the North Pole. So this would have been early 90s. And they had an American icebreaker with them, and they all got stuck in the ice. And there was a Russian nuclear powered icebreaker that came along. And not only did they free them and take them to the North Pole, but at the North Pole, they stopped and let out a whole bunch of school kids who then started dancing around. It was sort of embarrassing to the Canadians and the Americans, but it was a great scientific expedition, though. But nuclear ships, only audacious countries will use that technology at sea. So the States and Russia, probably China. I don't think we could afford it. Yeah, Eve.
I think I saw on one of the tests you had that only 2% of the CO2 is due to shipping. Was that correct? Or that?
Yeah, no, that's the numbers that I had was 2.2%. Yeah.
So why are we trying to go more environmental? Wouldn't it be safer to spend whatever money and everything on the 98 other percent, which might be, I don't know what they are.
I don't think that they're mutually exclusive, to be honest with you. We're in real trouble if we don't do well, we're already in real trouble. I mean, you know, the global temperature is not in equilibrium with the gaseous concentrations that exist in the atmosphere. I don't know if there's any climate deniers here. If there are, you should go home. There's just no question. There's just no question that it's anthropogenic in origin, and we're in trouble. I mean, we probably already hit the 1.5% level. We'll get 2%. When we were buying our house, we had to negotiate a mortgage really quickly because it was the last day that they would give a 10-year fixed rate mortgage. And I was flying off to Victoria. And when I got there, one of the first emails I read was from my wife, who said she checked with the environmental agency and our house was in the red zone, liable to be flooded once a year by 2050. I said, 2050, I'll be 96. I don't think I'm really worried, but it's too bad for the kids.
Thank you.
Yeah, Ian.
Thank you, Stephen. That was a very thought-provoking presentation. It was great. I come from no climate denier at all, but I'm of the opinion that this is a wonderful planet with a very bad infestation of human beings.
Yeah, I couldn't agree more.
There seems to be very few things that we talk about that wouldn't be, in fact, none, as far as I'm aware, that wouldn't be alleviated by there just being fewer people on the planet. In terms of, and I think this follows on from Eve's point, in terms of our human impact on it, your figures are really quite enlightening on that. And we talk about sort of like air pollution and from industrial concerns and so on. And then climate deniers will point out, yeah, every time, sort of like a volcano goes up, it flows billions of tons of CO2, and we can't do anything like that. I'm intrigued by the idea, we talk about, saving the planet. The planet hasn't got a problem. The planet would be perfectly happy if it was covered in sulfuric acid and so on. It's our possibility of remaining existent as inhabitants.
Yeah, no,
I was wondering if your figures go to the extent of, from a marine point of view, what's our impact as opposed to everything that nature actually does. Because this 2% thing that Eve was talking about does seem quite small. But on the other hand, I was horrified by your point about
okay, well, there's,
invasive species.
this
That's
was,
very worrying.
this was not a climate talk. That's another one I have tucked under my belt. So in terms of the 2%, I mean, the ocean is major absorber of CO2. And so that 2% is accumulating in the ocean. So what are the effects? Well, ocean acidification, which you've probably heard of. Ocean bleaching, which is a temperature effect on corals. I mean, the Great Barrier Reef has had several bleaching events, and each time they get worse and worse. I remember years ago, the chief executive from AIMS, the Australian Institute of Marine Science, based in Townsville, which is sort of the #1 investigator of the Great Barrier Reef. He said, if you want to see it, go soon. So there's all kinds of things. And, we focus on CO2 because of the Keeling curve in Hawaii, which has been going up. But what convinced me about the whole climate debate was the VLAC conference in 1985. Now, I didn't attend, I read their report. At the time, I was doing a lot of atmospheric chemistry. This report was about the anthropogenic trace gases in the atmosphere. So maybe you remember 84 is when the British Geological Survey paper came out about the ozone hole. And it very quickly was determined that because of that, in fact, it was the next year, Critson and clever people, that it actually was due to CFCs. And so this conference in Villach had totted up the concentrations of all these various trace gases, whose concentrations were much less than CO2, but they're much better greenhouse gases. And so in the old days, and probably now, they used to talk about a doubling of the CO2. But in terms of a radiative effect, if you took into account these other trace gases, we were already halfway there. Okay, so they accounted for like 50% of the CO2 increase. So, and they were anthropogenic. Now, amazingly, so you can tell I've done a lot of environmental science and with that. Amazingly, things like the Montreal Protocol stopped the use of CFCs pretty quickly, which is why, refrigeration science took off in the 80s because they had to find alternatives. Ammonia not necessarily being a smart one. Our spray cans, we used to have CFCs in them. Now a lot of them have got butane in, so don't use them near an open fire. That, of course, is the movies, right? James Bond got his deodorant and a lighter. I can go on a long time, I'm afraid. But are there any more questions? There was a lovely seminar at UBC. I didn't go, but my colleagues told me about it. This famous physicist came in and gave a talk, hundreds of people, and he whispered to the MC at the end of his talk. And the MC said, so will answer any intelligent questions. At which point, everybody just laughed. So I don't know if that's a good one for me to finish on. I'll answer any intelligent questions that you may have. But thank you very much.